Okay, so this is the video lesson for vertical and horizontal asymptotes. We are going to combine both of the lessons together just because both are shorter concepts, and really for the most part you already know how to do these. So just taking a look at this function, f of x is 1 over x squared. If you remember back to grade 11 pre-cal when you were doing absolute value and reciprocal functions, you know that whenever we have a non-permissible value in that denominator, that's going to be a vertical asymptote. So we know we're going to have a vertical asymptote at x is equal to 0. And if we plug in numbers into this function, we can see why that behavior does that. Why when we approach 0, we go up to infinity. Well, take a look. If we plug in the x value plus or minus 1 into this function, we get 1 over 1. Then as we plug in values closer and closer to 0, so 0.5, 0.2, 0.1, 0.01, the y values just skyrocket. They approach infinity. Because let's remember, 1 over a very, 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 very small number is a big number. 1 divided by 0.01 squared, well, the output's a very big value. So yeah, we see we approach infinity on both sides here. So we are going to take a look at vertical asymptotes, and then how do we know if it approaches infinity or negative infinity to the left and to the right of the asymptote. So again, x is equal to 0 is the vertical asymptote. You do want to include, don't just say 0 is vertical asymptote, x is equal to 0 is the equation of that asymptote. So let's move forward. Let's look at two things here first. Just move this up here. Okay. Just quickly, let's review over. Let's find the limit of 1 over x as x approaches 0 from both the right-hand side and the left-hand side. Now, we can't simplify this anymore, but what does it really mean to approach 0 from the right and 0 from the left? Well, we're just plugging in x values that are getting really, really, really close to 0. So, 0.1, 0.01, 0.001, and we're going to see at that asymptote, x is equal to 0, are we approaching infinity or negative infinity? Well, let's take a look here. We know that x is equal to 0 is a vertical asymptote, again, because of that non-permissible value that can't be simplified out. And so let's find the limit as x approaches 0 from the right-hand side of this function. Well, it would be impractical to plug in a table of values here. So plug in the 0.1, 0.01, 0.001. Instead, let's think about this for a second. We know we can't actually approach 0 because that's the asymptote. But we can imagine, well, what does 0 plus mean? 0 from the right-hand side. That means infinitely close to 0. So we're approaching it from the positive side. So instead of plugging in values here, making a table of values, let's just, yes, we know it's going to be a very, very, very small number close to 0, but it is going to be positive. So 1 over a very, very, very small positive number, as we continue to approach 0 from that positive side, we are going to be approaching positive infinity. And the same logic goes for when we approach 0 from the left-hand side. We can't actually reach 0, that's an asymptote, but we can approach just from the left of 0, so very, very, very small negative values. And 1 over a very small negative value, we know that 1 over a tiny number, or infinitely approaching a small number, is infinity, but this is going to be negative infinity. 1 over negative small number. So really, when you do graph that, so we know to the right of the asymptote we're approaching infinity, to the left of that asymptote we're approaching negative infinity, so just a really rough sketch. At 0, yeah, so to the left of 0 we're approaching down to negative infinity. Then to the right we are approaching up to infinity. And I mean, we could graph the rest of this function, but just finding these asymptotes and whether it's plus or negative infinity, this is the information we're finding. Okay, So finding the asymptote sometimes, it's similar to infinite or limits as x approaches infinity. Sometimes we just have to use our reasoning skills, I guess you could say, to find the value of certain limits. So taking a look at this function right here, we see that x is equal to 6 is a vertical asymptote. It's a non-permissible value down here. Oh, it's getting all fuzzy. Come on, focus yourself. Perfect. And we think to ourselves, okay, well, x is equal to 6 is a vertical asymptote. But what is the behavior just to the left of 6, just to the right of 6? Am I approaching infinity? Am I approaching negative infinity? Well, we kind of just have to think this one out. So again, we are approaching 6 from the left and from the right-hand side. And let's think about this. If I was to take a number infinitely close to 6, but just to the left of 6, so 5.999999, well, okay, so infinitely close to 6, 5.999, minus 6 gives me a negative, extremely small number, but squaring it makes it positive. The same thing as if I took a number just to the right of 6, 6.000001, well, that number minus 6 is positive, a tiny number, but squaring it makes it positive. So really, it doesn't matter if we approach to the right or to the left of 6, we get an infinitely small positive number. And let's think what really happens here. So as x approaches 6, that x minus 6 squared approaches 0, but positive. So therefore, this entire term here approaches infinity. 5 over an infinitely small positive number approaches infinity. So really, this entire limit is 2 minus all of this is infinity. So really, we're approaching negative infinity on both sides of that asymptote. At 6, we're approaching negative infinity from both sides. So really, there was not as much algebra in this question. It was really just thinking it out. Okay, as I approach 6, what's going to happen to this? Well, that's going to be an infinitely small positive number. 5 over an infinitely small positive number is positive infinity. 2 minus positive infinity minus infinity. So sometimes there's not some algebraic step. It's really just kind of thinking it out, identifying the asymptotes and thinking, well, what would happen just to the left, just to the right of that asymptote? So to find the vertical asymptotes of a rational function, we find the x values where the denominator is 0 and compute the limits of the function from the right and the left. Now, the way that I taught my class limits is if the limit was infinity or negative infinity, we said it did not exist. Well, this is one of those applications where we don't want to say does not exist. We do want to say approaching infinity or negative infinity because that will help us determine if the asymptote is going up or down. Okay, so let's find the vertical asymptotes of the function. Here it is. And we're actually going to use this question multiple times during this lesson. So let's find the vertical asymptotes. There's my function. I note that denominator we can factor. So I'm going to factor that denominator. And I see my non-permissibles that can't be simplified out are 3 and negative 2. So x is 3, x is negative 2. But that doesn't tell me if the function goes up to infinity or down to negative infinity on either side of those asymptotes. So what we are going to do is, let's start with evaluating at x is equal to 3. Okay, hold on one second here. I'm just going to do a little clever. Okay, let's evaluate at x is equal to 3. Let's take a look what I do here. So I'm going to start to the left of 3, the left-hand side. So the limit of that function as we approach 3 from the left-hand side. Now again, I am approaching the asymptote, so I know it's going to approach infinity or negative infinity. That's what happens at a vertical asymptote. We know that. We're going to infinitely approach that line without reaching it. So instead of, again, making a table of values and plugging things in, let's just assume that we are going to approach 3 from the left-hand side, and we are going to take a value infinitely close to 3 on the left-hand side. Well, what value could be infinitely close to 3 on the left-hand side? Well, 2.9999. Let's imagine that's the x value we're kind of looking at. So if I plug in 2.999 or a value to the left of 3, that would give me a positive up here. What about 2.99999 minus 3 in this bracket? Well, that's a negative. Just barely negative, but it's negative. And then 2.999 plus 2, well, that's positive. And then we think a positive divided by a negative times a positive. Well, that's negative, so we approach negative infinity. This is the technique for finding if you are approaching positive or negative infinity at the asymptote. We just plug in a value either to the left or the right of the asymptote, but we're not actually plugging it in. We're just finding out if we're approaching positive or negative infinity. We don't have to actually plug in the number here. Not very practical. So the same thing, let's find, as we approach 3 from the right-hand side, let's do the same thing. Let's plug in a number just to the right of 3. Infinitely close. I don't know, 3.0000001. Well, that's positive up here. Well, just above 3, just to the right of 3 minus 3 is positive. Then positive, so all of it's positive. Yep, so when we approach 3 from the right-hand side, x is equal to 3 from the right-hand side, that asymptote's going up to positive infinity. And really, the exact same technique as we approach the asymptote negative 2. Let's take a look at my work over here. So here is both of them at the same time. Maybe I'll just show you one to start. So approaching negative 2, that asymptote, I'm going to approach from the left-hand side first to find its behavior. What's a number that's just to the left of negative 2 on a number line? Well, negative 2.01, just to the left of negative 2. So that's negative up here. Negative 2.01, or just to the left of negative 2 minus 3, that's a negative. Then just to the left of negative 2 plus 2 is still negative. Just to the left of negative 2 plus 2. So minus divided by minus minus approaches negative infinity. And the same thing as we approach negative 2 from the right-hand side. What's a number that's just to the left of negative 2 on the number line? Negative 1.999, sure, let's think about it that way. So that's a negative up here. Negative minus a negative, still negative. Negative 1.9 plus 2 does bring me back over to the positives. So negative divided by a negative positive. We approach positive infinity. So let's actually look at what that means. Again, as we approach 3 from the left, I'm at negative infinity. As we approach 3 from the right, positive infinity. Negative 2 to the left is negative infinity. Negative 2 from the right, positive infinity. Now, what does this information tell us? Now, this is just a very rough sketch, but this is what we can get from that information. My two vertical asymptotes at x is equal to 3, x is equal to negative 2. And I saw to the left of negative 2, I was going down. To the right of negative 2, going up to infinity. To the left of 3, down to negative infinity. To the right of 3, up to infinity. Now we're going to have vertical asymptote, horizontal asymptote. This function is going to have a lot more to it. But for now, just in pink here is the information we got just from doing this vertical asymptote work, I guess you could say. So let's move on to the next part. That's vertical asymptotes. Very similar. All your questions are going to be very similar to that algebra. So let's look at horizontal asymptotes. To find horizontal asymptotes, we are going to find the limit of that function as x approaches infinity and the y value, or the limit, as x approaches negative infinity. Let's note something here. The solutions to these horizontal asymptotes are 0 and this one is 0. Because remember, 1 over infinity is 0, or 1 over negative infinity, 1 over a massive number, 1 over a massive number, 0 both times. So horizontal asymptotes are a little bit different than vertical asymptotes. You actually can cross through a horizontal asymptote in the middle or center of the function. But it's when we get to the infinities, it evens out and doesn't cross the asymptote. So really, this doesn't really make as much sense. You know what, let me do this again here. If we were to have a function So I'm going to draw a Cartesian. And if we had a horizontal asymptote, it is possible to cross the function within it, but it's when we get to the infinities, it evens out. When we get to the infinities, it evens out. So let's take a look at this. Let's find the horizontal and the vertical asymptotes of this function. Taking a look, actually I'm going to center this a little bit more. Go on over here. Taking a look, x is equal to 2. That's going to be a vertical asymptote. So let's do the horizontal asymptote first. Let's find the limit as x approaches infinity. What y value do we eventually approach? Hey, finding the limits as x approaches infinity or as n approaches infinity, like we used to do. Divide the top and the bottom by the highest power of x. So I'm going to do that. Divided by the highest power of x. Simplifies down to that, which simplifies down to 1. So y is equal to 1 is my horizontal asymptote. Y is equal to 1 is my horizontal asymptote. Meaning as I approach the infinities, my function approaches y is equal to 1. And you can even do the same work for approaching negative infinity. Doesn't matter, you get the same y value. So just a really rough sketch of this. I'll let you do the vertical asymptote work yourself. We know that vertical asymptote is at x is equal to 2. And I drew my horizontal asymptote at y is equal to 1. And this function actually doesn't cross the horizontal asymptote ever. But as we see, so my vertical asymptote to negative infinity, and as I approach negative infinity, I even out and I approach y value 1. There's my vertical asymptote. As I approach infinity, I approach y value 1. So really you're just finding as x approaches infinity, the limit as x approaches infinity of the function to see if there's a horizontal asymptote. Okay. One more example, and I am going to carry this forward. Again, we just did the example before, this same function. So give me just one moment here. Okay. Let's find the horizontal and the vertical asymptotes of this function. Now, we did do this exact same function before, so we already know the vertical asymptotes. But let's find the horizontal asymptotes. So horizontal asymptote, let's find the limit of that function as x approaches infinity. I'm going to divide the numerator and denominator by the highest power of x, which is dividing the numerator and the denominator by x squared. And then we can simplify, this is going to be 1 over x, this is just 1, so on and so forth. And then let's actually approach infinity, so that ends up being 0 over 1. So y is equal to 0 is my horizontal asymptote. Now again, you can cross through a horizontal asymptote, just as we approach the infinities is when they even out and approach that value. And how would we find the vertical asymptotes? Of course, we would factor. So x is 3, x is negative 2. We just did this question. And here's the answers from before. Check back a minute or two to see how we got these. Again, approaching negative 2 just from the left, plugging in those values to the factored form. So to the left of negative 2, negative infinity. To the right of, I should say negative 2, positive infinity, so on and so forth. So when we get all of this information, we can give a really rough sketch. And here it is. So I drew my Cartesian. I extended my horizontal asymptote out a little bit so you can actually see it, labeled it, vertical asymptotes. I applied my knowledge of the vertical asymptote, so negative infinity, infinity at this one, negative infinity, infinity at this one. And look, hey, I crossed the horizontal asymptote, but you can kind of in the quote-unquote center of the function. It's when we approach negative infinity, I don't cross it. When I approach infinity, I don't cross it. Note, horizontal asymptotes only tell about the function as x approaches infinity or negative infinity, like I just said. Often they can cross in the middle of the graph or around 0. So your homework will go over questions just like this. Vertical asymptotes really only has that one technique, same with horizontal asymptotes, and that is pretty much it for new information for the year.